This is problem number 4 on the sample test problems for test number 2. Find the 15th derivative of y equals x to the 14 plus sine x plus e to the 2x. All right, 15 is a lot. We start with the first derivative, y prime equals, okay, first derivative of x to the 14, 14 comes down, subtract 1 from the power, plus, derivative of sine is cosine, plus, and we've got a chain rule here, derivative of e to the 2x is e to the 2x times the derivative of that power, and the derivative of 2x is 2. 1 down, 14 to go. Y double prime equals. Okay, the 13 is about to come down and multiply by 14. We don't actually want to write down what that product is because I think that takes away the pattern. I'm interested here more in the pattern than in the actual number, like how much is 14 times 13. So I'm just going to write the 13 is like really just coming down there. Derivative of cosine is negative sine, plus, okay, what do we do with the 2 here? Let's see. So the 2 is a constant multiple. I'm going to come back to it. So it's the derivative of e to the 2x is e to the 2x times a 2. But then there's this 2 that was here from the beginning. So what I'm going to do is merge those 2's together. But instead of writing 4, I'm just going to write 2 times 2. In the same vein as we wrote 14 times 13, I really want to see the pattern more than writing the number 4 there. Okay, y triple prime equals. Okay, 12 comes down and joins its compadres. 14 times 13 times 12. Subtract 1 to get x to the 11. Derivative of negative sine is negative cosine, plus, okay, e to the 2x. There was a 2 there, there was a 2 there, and then now the new derivative of e to the 2x is e to the 2x times the derivative of the 2x, which brings down yet another 2. So I feel like I'm just about there in terms of the pattern with the 2's. I'm going to write one more derivative here, y to the 4 equals, so the 11 comes down, 14, 13, 12, 11. Subtract 1 to get 10. Derivative of negative cosine is plus sine x. Plus, and then I feel like we're going to get another 2 here, so let's just write 4 of them. All right, and now I just want us to try to figure out what the pattern is. I don't want to go all the way to 15. But I want to look for patterns here. So let's see if we can get maybe part of the answer. So the 15th derivative equals. So let's look at the last part first. Let's look at these 2's and the e to the 2x. So when it was a 4th derivative, we had how many 2's in the front? Let's see, 1, 2, 3, 4. Okay, 4th derivative, we had 4 2's. When it was the 3rd derivative, we had 3 2's. Oh, that's pretty good. So then when it's the 15th derivative, we're going to have 15 2's. But instead of writing all 15 of those 2's, let's use the shortcut. The shortcut is just 2 to the 15th. And then e to the 2x was constant in there. Okay, so what's next? So that's the e part. Let's look at the sine part next. All right, the first derivative was cosine. Second derivative was negative sine. Third derivative, negative cosine. Fourth derivative, positive sine. And I just want to acknowledge that that is right back to where we started. And this is something we knew, right? That the derivative of sine repeats after 4 derivatives. So let's see, the 4th derivative gets us right back to sine. So what's the next derivative that gets us back to sine? Well, that's the 8th derivative. And then what's the next one after that? That's the 12th derivative. And then I think we're getting kind of close to the 15. So I guess what I'd be okay saying is that maybe just in terms of the sine part, I kind of buy that if I had the 12th derivative here, other stuff would be different, but that would be a sine x. And so if that's sine x on the 12th derivative, I'm trying to get to the 15th derivative, and one derivative from that sine x is this cosine x up here. So I feel like maybe the 13th derivative has a cosine there, and then the 14th derivative has a negative sign, and then the 15th derivative, the one that we want, has negative cosine. And so I really feel like that's our answer. That's the remnant of sine x as it oscillates around when I do 15 derivatives. So I'm feeling pretty good about putting negative cosine x in our final answer. Another way we could have done that, I guess we had said that the 12th derivative was a special one because that gets us right back to the original sine x. The next one would be the 16th derivative, so I guess I could have said 16th derivative has sine x. And then the 15th derivative, instead of winding around forward, we could just say, oh, the 15th derivative was one before. And again, we land on negative cosine x. So I think that's going to be in our formula. Let's get rid of all this stuff here. Okay. So where are we here? So I guess we say it was a negative cosine x. And then plus that. Just in case I give you a much bigger number, like if I had said not the 15th derivative, but the 150th derivative, probably don't want to sit there counting by fours. I'll leave this to you to kind of think about, but really the problem you want to do is 4 into 150. How many times does it go? And more importantly, how many times, more important than how many times does it go in is what's the remainder? And the remainder would just pick off one of these 4 highlighted yellow things. If the remainder is 1, you're in that row, remainder 2, that row, remainder 3, that row, remainder 0, that row, or equivalently the original function. You can think about that. Okay, so the last piece of this puzzle is the polynomial part in the front. So let's see, when we did a first derivative, we had a 13th power, second derivative was a 12th power, third derivative was an 11th power, fourth derivative is a 10th power. I guess the question is what power will be up there when we get to the 15th derivative? So let's see, we're continuing this kind of trend here. Maybe how about we look for a pattern. When it was a fourth derivative, we had a 10th power here. And I'm just going to observe that 4 plus 10 is 14. That's a pretty big observation. Isn't that bold of me? Okay, so that's 14. And then I'm going to go to the next one. The third derivative had an 11th power. The third derivative and the 11th power, oh, it's 14. Let's see if this is a pattern. Second derivative, 12th power. 2 plus 12, 14. So I think what I'm starting to believe here is that if I take the order of the derivative and I add the power, I am going to get 14 every time. I take the order of the derivative and add the power, I get 14 every time. Okay, so what order am I looking at in this problem? Well, in this problem, the order is 15. So somehow, the order of the derivative plus power that I don't know has to give me that magical 14 that we kept getting over there. So what power must it be? Well, let's see, 15 plus -1, that's the only thing we can put in there. So somehow the x has wrapped around, it's gone past all of the positive powers, it's gone past 0, and now we're to x to the -1. Is that right? Well, let's kind of fast forward to the end of this game. So at some point, the power is x squared. And then when you take the 2 down and then subtract 1 from the power, it becomes x. And then when you take the 1 down and subtract 1 from the power, it becomes x to the 0. But anything to the 0 is 1. And so when I get to that spot, the term that I'm looking at is just going to be a constant. I'm not saying it's going to be 1. It's going to have 14 times 13. I mean, it's going to be all this stuff, and it's going to continue. And actually, you guys might already know a little shorthand way for exactly what that product is going to be. 14 times 13 times 12. It's going to go all the way down to 1. So when I get there, it'll be 14 all the way down to 1, but then it'll be a constant. And then when I take one more derivative, does this guy go to x to the -1? No, because it's not there anymore. You didn't even write it as x to the 0. You just wrote a constant. And when you take the derivative of that last constant, what do you get? Well, the derivative of any constant is 0. And so in this case, I mean, it never goes to x to the -1. It disappears before it gets there. So actually, the 15th derivative of this thing is 0. So I think we've got our final answer. We'll box it here in red. Now maybe another question to think about, and I encourage you to think about this before the test, is actually figuring out, well, what happens right before it was 0? Can you write out what the derivative of all that stuff, all this original stuff here? What's the 14th derivative of that? In some sense, that one's harder than the 15th derivative. That's one step before the constant disappears. So we'll leave that as an exercise. I think we've got our final answer in the red box.